Hi guys, what I figure I would do today, because I had a little bit of downtime, is go through an ANOVA calculations and show you how I do it, just as another example. This is no lecturing, just the steps that I take in order to do this analysis by hand. So I'm going to go through it, and the formulas I've already uploaded using the same sheet that I uploaded. I don't know if you can see it, probably not, it's a little fuzzy, but it doesn't matter because you have it up on Brightspace. So let's go through it without further delay. This is what you'll be receiving. The spreadsheet or the grid that I have, you'll just have 4 different groups and 4 different sets of data. It's not so much the input that's important, but it's the process that I take. So let's go through it. So the first thing that I always do is I like to do my low-hanging fruit, as I say. So the first thing I'm going to do is I'm going to find my totals. Okay, I'm just going to add up this entire column, just like this. And I know I have 6 people in this group, so I'm going to find the mean. Okay, so it'd be this divided by 6, have the mean. And now what I want to do is I want to get my sums of squares. So the first thing I do is my score minus the mean. Okay, I do that. Let me just set this up real quick. Make it go a little quicker. Okay, and I just do that for all the values. And then I make sure it's equal to 0, which it is. Then I drop the plus and minus and multiply the score by itself, just like this. And I bring it down. And I do that for each of them. Then I add this up, this column. Here are my sums of squares. And then I just plug the value in over here. Okay, now I replicate that for the 3 other groups. So let's just do that very quickly. I add this up, I sum this. Okay, I sum it up. I get the mean. And then I go through the same process. My score minus the mean. Okay, just like that. And let me just set it up real quick. So I have it. Hold on. There you go. And then I do that for each of the values. And then I make sure that it equals 0, which it does. Now I drop the plus and minus sign and I multiply it by itself. And I do that for the remainder of the values. And then I add it up. And then I have my sums of squares there. And I put it over here. And I do the same for the last 2 groups. Okay, here it goes. All right, I add up the column. Okay, then I find the mean. Okay, and then I go back up and I do the score minus the mean. Hold on a second, let me just do it. Got the score minus the mean, and then I do the plug and the chug. Hold on. Right, then I do it for the rest of the column. And then I add it up to make sure it equals 0. Drop the plus and the minus, multiply it by itself. It's like that. Whoops. Okay. And now I just copy it down, so to speak, do it for the rest of them. I add it up. Okay, and I have my sums of squares there. All right, now what I do is I do the final group and I add up these guys. Hold on. Okay, here we go. And I get the mean. And you've seen this before, score minus the mean. Okay, hold on a second. Almost there. Can I do that for all the scores going down? Process, I make sure it equals 0. Drop the plus and the minus sign and multiply the value by itself. Okay, and then I go down and then I add it up, and there are my sums of squares. Okay, and I copy it over here. Next thing I want to do, now I've taken care of the top half of the matrix. Once I take care of the top half of the matrix, I can move forward. And here I look at this value called x squared. What I'm going to do here is I got 24 values, that's my capital N, and what I'm going to do is I'm going to create a column. I'm just going to take the scores and append them in a column. So I take this, okay, I put those there. That's my first set. I do this for the next 3, copy it. Okay, hold on. Okay, there's the next one. Now I got 2 more to do. Copy them. Okay, down here. And I do the 4th one. And I copy it. And I put it down here. Okay, so I should have 24 scores. Let me just edit this for a second. I kind of like symmetry. Okay, once I have all the 24 scores listed like that, then what I'm going to do is I'm going to multiply each one by itself. I'm going to square each one. So there you go. And as you can see, the numbers are squared. So if you look down here, you can see each number has been multiplied by itself. And then what I'm going to do is I'm going to add up that column. Okay, so here you can see the column is being added, all the data is being put in here, and there's the value of summation x squared. Once I get through this point, so right now what we've done is we've taken care of the top of the matrix, we've gotten the totals, the means, and the sums of squares. Then we move to over here, where we've gotten the x squared. We've taken each of the individual scores, put them in a column, multiplied them by themselves, added it up, summation x squared, and we have that. Now we're ready to move over here to start to fill in some of the definitions. So we have, first one we have is capital N. Capital N is all of the elements that we're operating with. So we have 4 groups, 6 people per group. That's 24 people. So my capital N, or my total is 24. So you just put that in. GT, grand total. Do we have a formula? Sure we do. And the formula for grand total is total of 1 plus total of 2 plus total of 3 plus total of 4. Let's go do that. So we said it's the total of the first group plus the total of the second group plus the total of the third group plus the total of the fourth group. So you see where those numbers are coming from, right? So it's T1 plus T2 plus T3 plus T4. Add them up, got that. Summation x squared, we already did that. So the number there is 1298. I just go over here and I just plug it in right here, 1298. The next value that we're looking to fulfill, or the next value we're looking to find, is K. And on the sheet of paper that I uploaded with the formulas and the definitions, K is number of groups. And the number of groups we have is 4. So far, everything is being laid out in front of you. And as I said, I do all these statistics, and the way I set up my sheets is that we prepare for the next step. We prepare for the next step. Small case n is number of elements in each group. We have 4 groups, we know that. But how many people are in group 1? 6. How many are in group 2? 6. Group 3, 6. Group 4, 6. So the number of elements in each of the groups is 6, so we just put 6 here. Capital N is everybody all in the same boat. Small case n is just the number in each of the groups, okay, unadded with each other. Once I have this completed, I know I have to concern myself over here. Okay, so here you see degrees of freedom and sums of squares. So we have to calculate 6 things. We have degrees of freedom total, degrees of freedom between, and degrees of freedom within. And then we're going to calculate sums of squares total, sums of squares between, and sums of squares within. All right, so let's do it. Do we have formulas for each of these things? Yes. Do you have the formulas in front of you while you're doing this? Absolutely. So you can just do it the same way I do. So degrees of freedom total, the formula is n minus 1. So n is 24. 24 minus 1 gives me 23. Degrees of freedom between is k minus 1, right? Degrees of freedom between is k minus 1, number of groups minus 1. So we have 4 groups minus 1. 4 minus 1 is 3. And then all I do to solve for degrees of freedom within is I just subtract total minus between, or 23 minus 3. Oh, I want to use 3 now, 5. Okay, it's 20. All right, so the degrees of freedom total between and within, pretty simple to calculate. Just follow the roadmap and you're good to go. All right, so now we get to sums of squares total. Sums of squares total is, the formula is, if you look at the sheet of paper, is summation x squared minus gt, take a breath, squared, divided by capital N. Okay, so let's start putting that in. So look at the paper, you see the formulas, summation x squared minus gt, take a breath, squared, divided by capital N. So we have the numbers right here. 1,298, right? Minus gt, which is 168, and we're going to square that. Okay. Divided by n, which is capital N, which is 24. All right, let's see what this does for us. Okay, there it is. So we have 122. So summation x squared minus gt, take a breath, squared, divided by n is 122. Now what we do, instead of doing sums of squares between, we're going to do sums of squares within, because that's an easier calculation and we can just back it out from there. Sums of squares within, if we look at the formula, is adding up all the sums of squares. So sums of squares within is going to be 20 plus 20 plus 14, which is sums of squares 3, plus 8, which is sums of squares 4. So I'm just adding up all the sums of squares. And here, I just solve for x. So I'm just going to subtract sums of squares total minus sums of squares within. So that'd be 122 minus 62. And there I am. I have these 6 elements now taken care of. Now this takes me to my next step. We know that for the F ratio numerator is mean squares between divided by mean squares within. But we don't have the mean squares yet. We need to calculate them. So how do we do that? Do we have formula? Yes, we have a formula. And the formula for mean squares between is degrees of freedom between, MS between is, sums of squares between divided by degrees of freedom between. Okay, so let's do that. Sums of squares between, do we have that value? Yes, sums of squares between is 3, divided by degrees of freedom between, which is 60. I have no idea what that popped up. Okay. Whoops. That did not work well. Sums of, oh, I had it backwards. Okay, I'm sorry. Sums of squares between is 60, divided by degrees of freedom between is 3. Okay, I knew there was something wrong there. Okay, so that looks a lot better. Okay, but you have the formula here, and this is why you always need to check. That's why pencils have erasers and stuff like that. And for the denominator, which is mean squares within, is we follow the same format. So it'd be sums of squares within divided by degrees of freedom within. Okay, so sums of squares within is 62, divided by degrees of freedom within, which is 20, and we have that. Okay, so now we're ready to do our F ratio, which is the relationship between the buckets by what's within the buckets, and I said that's simultaneous. So let's do an F ratio. So it would be mean squares between, let's see here, mean squares between is 20 divided by mean squares within, which is 3.1. And our F ratio is 6.45. Well, that is a statistically significant F ratio. I don't need an alpha to tell me that, because for this class, if it was not significant, if we accepted the null and rejected the alternate, then we would just stop the analysis right here and say that there's no difference between anything. But because we're going to go through the eta squared and the Tukey, it's going to be significant. So your statement right now would be, we have an overall statistically significant model. Okay? And now we're going to do our second pillar, which is eta squared. And do we have a formula for eta squared? We most certainly do. The formula for eta squared is sums of squares between divided by sums of squares total. Sums of squares between is 60 divided by sums of squares total, which is 122. And we get 0.49. And what did I say about eta squared? It's a combination Cohen's d and r squared. And anything above a 0.35 is an extremely stable model. So the second pillar, what we can say is, okay, we have an overall statistical significant model, okay, and the magnitude of effect, R squared combination, or the eta square, indicates to us that this model is a very powerful model. All right, 0.35, now we got a 0.49. That's telling us that it's a very stable finding. Okay, so Tukey. So now the question that's begged to be asked, hold on, let me put this in here. The question that's begged to be asked is say, okay, what's driving the differences? We have an overall model, we know that, and there's differences between these groups. There are differences between 1, 2, 3, and 4 groups, but we don't know what's the direction, what's pulling which one is pulling, which one is pushing, which one is really causing a difference. Are they all different from each other? Is one group just different from each other? We don't know. So what the post hoc test does, post hoc meaning after the fact, what the post hoc test does, it helps us identify which groups are different from each other and which groups are similar to each other. Okay? That's what the post hoc does. And we have the Tukey. And do we have a formula for the Tukey? Yes, we do. The formula for Tukey is Q times mean squares within divided by small case n square root. Now, a lot of folks, when I saw on the t-test on the second exam, I don't know what some of you guys were doing, but you weren't doing the square root stuff right. It's everything under the square root gets done first, and then you hit the square root key. Some folks weren't doing that, and you're getting weird results. I let it go, but I can't let it go when it comes to doing the Tukey, okay? So just be aware that it's everything under the radical, everything under the square root key gets performed first. So if there's some division that needs to get done, so we're going to do the mean squares within divided by small case n. We'll get that value, and then we hit with the square root key. So here we go. So let's just do it here off on the side. So mean squares within, Okay, mean squares within is 3.1 divided by small case n, which is 6. So we get that. Now what I want to do is I want the square root of that. So on my calculator, I would hit the square root button. But here on the spreadsheet, I'm just going to go square root, and I'm just going to say use this value in here, and here's my value. Okay, this is the square root of that number. So I did the math first, then I hit the square root key. Now, with my formula, it is Q times mean squares within divided by n square root. So let's put it all together. So I'll put it over here. So it's Q, which I have here, which I've given you on the exam, 3.69 times, and I'll just move over here. Just do it this way. Okay, 2.65. So that's where I come up with my Tukey value. What do I do with this Tukey value? All right, so here on the side here, I have my combinations. I have all the combinations for 4 groups. 1 versus 2, 1 versus 3, 1 versus 4, 2 versus 3, 3 versus 4, 2 versus 4, okay? I have all my combinations identified. And what I'm going to do is I'm going to compare the means of those groups. 1 versus 2, then 1 versus 3, and so forth and so on. If that difference between the means is greater than our Tukey value of 2.65, then we know that there is a significant difference between those two groups, and we're going to mark it accordingly. So let's see how this works. So the first combination that we're going to look at is the mean of the first group and the mean of the second group. Well, the mean of the second group is 6. The mean of the first group is 5. 6 minus 5 is 1. 1 is not greater than 2.65. So what I do is I put an X in there to demonstrate that they're similar to each other. Next group is 1 versus 3. The mean of 3 is 8. The mean of 1 is 5. 8 minus 5 is 3. 3 is greater than 2.65. I say, yes, there's a difference. That's how I mark it with my X's and my Y's. So I know X means Nixie. Y means that there's a difference. So right now I know that there's a difference between groups 1 and 3. Let's look at 1 and 4. Mean of group 1 is 5. Mean of group 4 is 9. 9 minus 5 is 4. Looks like it's a difference. Put a Y in there. 2 versus 3. 8 and 6. Mean of 3 is 8. Mean of 2 is 6. 8 minus 6 is 2. That gets a Nixie. That gets an X. 3 and 4. 9 minus 8 is 1. That's a Nixie. And 2 and 4. 2 is 6. 4 is 9. 9 minus 6 is 3. That is a yes. And then I say my two statements. The first statement is we have an overall statistically significant model, period, and that differences are coming from groups 1 and 3, 1 and 4, and 2 and 4, and we leave it at that. The discussion section that the authors will be writing up will tell us why that happened. The analytical section or the statistical section of a research paper is going to tell us what happened. And the discussion section is why it happened, well, whatever they infer about it. Okay? And that's what's required to get through this analysis of variance. Okay, so what I'm going to do is I'm going to upload this, and I'll send out an announcement that it's there. Any questions, you guys got to let me know. All right. Thank you. I'll have office hours tomorrow, so I'll talk to you then.